Okay, now we will be getting into the Route 53. This is also going to be a long lecture, so stick with me. So let's talk about the first record types in the Route 53. So, so we have the A type that maps to a hostname to IPv4. We have uh, a 4 times A types which maps to the hostname to IPv6. We have CNAME to map hostname to another hostname in which the target of the hostname must be an A type or 4A record. So A times A record, and you cannot create a CNAME on top of the node of the DNS namespace, okay, which is like is the zone apex. So you cannot create a CNAME, for example .com. Yeah, so for example .com, but you can create a CNAME for www.example.com, and we'll see how to solve that problem with alias records. And then finally we have NS records, which are name servers for the hosted zones, which control how traffic is routed to a domain. So these records are all you need to know for the Solution Architect professional exams, and don't worry about the rest, like the the records for the mail servers and other many records for the verification related TXT records or something like that. Okay. Now for an A record, how does that work? A record, how does that work? Well, the clients want to access an EC2 instance that has a public IP. So it's going to first query for example.com in Amazon Route 53 and then get an IP back. That is a 54.22.33.44. And then thanks to the IP, it would reach our EC2 instance. So this is for a very simple A record. Okay. Now let's talk about the difference of CNAME and alias. So all other resources in AWS, for example, load balancer, CloudFront, etc., they expose an AWS hostname. So for example, this is a hostname of a load balancer, lb1 -123.uss2-elb.amazon.aws.com. And maybe you want this load balancer to be instead to be actually having a custom domain, that is myapp.mydomain.com. So how would you do this? Okay, well, if you have a CNAME, as you remember, it is a hostname that points to any other hostname. So it is very possible for us to do app.mydomain.com points to anything.com. Okay, and so like blah blah dot anything.com. So it is very possible for us to do app.mydomain.com points to blah blah dot anything.com, and so therefore it would work for the example even the above for the load balancer. But this only works for the non-root domains, okay, not for the root domain. So it must be something .mydomain.com, that's a subdomain. So for an alias record, through it is different. How it is different? It's point to a hostname only to a specified AWS resource. So it's app.mydomain.com into something.amazonaws.com. So it is a must be a resource from AWS, and this works for root domain and a non-root domain. So it works for the mydomain.com and it's free of charge. Okay, this alias records is free of charge, and it has native health checks as a feature. So that means that for the like the load balancer in AWS, you cannot do a CNAME for mydomain.com, but you can do an alias record for mydomain.com. Alias record can be actually pointed to here the root domain and even to the subdomain, but the CNAME records can only be actually pointed to the subdomain, not the root domain. Now in terms of targets for alias records, we get elastic load balancers, CloudFront distributions, we get API gateway, elastic beanstalk environments, S3 websites, VPC interface endpoints, global accelerator, accelerator, so as well as any other Route 53 record and in the same hosted zone. And you cannot set an alias record for an EC2 DNS name. Okay, you cannot set for it for the EC2 DNS name. Now its record in Route 53 is going to have a record TTL. So which is a time to live. So here's an example. The client wants to talk to our web server. So this in the bottom is the web server. You are able to see that now. So, but we have a DNS request for the myapp.example.com, and we are going to get a response from example. For example, like as an A record that will have a TTL, and this response is going to be cached for the time of the TTL, and then once the TTL expires, then the record will be renewed. So while the TTL is still present, and the record is saved on the client side, then the requests are going to go to the IP that was fetched from before. So in case you do a high TTL, for example 24 hours, that means that you are going to get less traffic on Route 53, but you have possibly outdated records. For example, if you update them in the DNS side, then it will take up to 24 hours for the client to get the new values. Otherwise, if you set a very low TTL, for example 60 seconds, that means you are going to get more traffic on the DNS side, which is going to cost you some money. But on the flip side, the DNS records are going to be outdated for less time, and it's going to be easier to change records. Nowadays, all of the DNS providers, DNS endpoints will give you the option of the auto TTL. So in case the auto TTL, it would depend upon the type of the cache, that for how long it's going to be cached in the as of the TTL, for how long is going to be the TTL. And here, so it's always a trade-off, and except for the alias record, the TTL is mandatory for each DNS record, and this is very important to remember. Okay, now let's look at the routing policies. So we have the simple routing policy, which is to route traffic to a single resource, and this cannot be associated with a health check. And this is the only kind of the routing policy that is not associated with the health check. Okay, not associated with health check. So here's an example. So the client goes to foo.example.com and then gets a value back. This is super simple, but you can also specify multiple values in the same record. And if that's the case, then a random one is going to be chosen by the client. So the client is asking for a DNS request and then gets multiple values here as a result. So at the bottom that you are seeing that is the Amazon Route 53. So the client is going to choose a random value. Okay, so that's for the simple routing policy. Next we have weighted routing policy. So weighted gives you the ability to control the percentage of the request that go to a specific resource. So in this example, we have 70% of the request going to my first EC2 instance, then 20% to my second EC2 instance, then 10% to my EC2 instance, the last one EC2 instance, that's the weight is having 10. So this kind of record can be associated with health checks to make sure that we don't send traffic to a resource that is not healthy. The use cases for weighted records is around load balancing between regions, testing application versions, and so on. Then we have latency-based records, so which is to redirect resources that have the least latency. List latency close to us, which is super helpful when latency is user priority, and the latency is going to be defined on the traffic between the users and a specified AWS region. So it's very possible for Germany users to be directed to the US ALB if that's the lowest latency. And for example, your app is in Asia, so these kind of records can be associated with health checks as well, which gives you a failover capability. So if we have, for example, the two ALBs, one in the US East one and another one in the AP Southeast one, I think it's the Singapore, yeah, we saw this one. Then our users all around the world, it's very possible for these users to go US East 1, and for the others go to the AP Southeast one, starting from somewhat in the Russia and India. AP Southeast one, and in the other from the Europe region and the Canada region is going to the LB US East one. So next we have failover for active passive type of record. So we have a primary record and then a secondary disaster recovery record, and so there's going to be a health check performed on the primary one, and that then in case the primary fails, then we are going to have a failover to the second instance, and this will be characterized by DNS request that either reply with the first EC2 instance or the second EC2 instance. Then we have geolocation, which is different from latency based. So this is to route based on the user location itself. So you can specify by continent, by country, or even by the US states. So you can and if you have overlapping, then the most precise location is going to be selected. So you should create a default record in case you have no match on location. And the use case for the geolocation is to be doing website localization and to restrict content distribution or load balancing. And these can be associated with health checks also. So as an example, we have a map of Europe right here, and some Germany users could be sent to this record. Each French users could be sent to the other record, and then anyone else could be sent to the default IP right here, and that's in the somewhat in the Asian region. Another one is called the Geoproximity, which is to route to resources based on the geographic location of users and resources. And thanks to something called the bias, you can shift traffic to some resources more or less based on that number. So you change the bias value to expand the traffic to the resource, okay, and you are going to increase it from the 1 to 99, or to shrink, you are going to decrease from the -1 to -99, which is going to send less traffic to that resource. And the resource could be an AWS resource, or it could be a non-AWS resource. And in that case, we need to specify a latitude and a longitude for the geoproximity, and for it to be effective and to be set up, you need to use the traffic flow. Only the traffic flow feature of the Route 53 can implement this geoproximity routing policy. So now let's see the geoproximity routing policy with a diagram and how that works. So if you have US West 1 and US East 1, two region, and then they are going to be having the bias 0, 0. So you are going to get a line in the center of the US geographically, and so half of the users are gonna go to the west and half the users go to the east. But in case you increase the bias in US East 1, and for example you set a bias to something much higher, say 50 in the US East 1 region, and you leave it to 0 on US West 1 region, then the line is going to be closer to US West 1, and therefore more users to the right of the line are gonna go to the US East 1, and other ones are gonna go to the US West 1. So with the bias, you are able to really manipulate how much proximity you want users to be next to the locations, which brings us to the traffic flow. And forget about my actually hand gestures that been left and right being confused a little. Not confused because of this here. I'm recording here as of the camera, and the camera is not have been camera view is somewhat in the opposite direction. It has not been not been rotated 180 degrees or something. So that's why it's giving me a little of the issue. So now the traffic flow, we'll be seeing the traffic flow, how we'll be using this, and what's the charges for the traffic flow. Okay, So the traffic flow is a feature of Route 53 which allow you to easily create and maintain very complex and large records as well as geoproximity records. So it's a visual editor. If you edit one of the traffic flow, if you will actually draft one of the traffic flow in the visual editor, you will pretty easily understand all of the routing policies. So it's a visual editor and gives you complex routing decision trees available to you that you can set up easily, and these configurations are saved as traffic flow policies, and they can even be applied to different hosted zones and if you need to so, and they support the versioning also. Then we have last type of record called multi-value record, which is to use when I'm sorry for mic. Finally, we have last type of record called the multi-value record, which is to use when routing to multiple resources, and when the Route 53 is going to return multiple values and resources. But because these can be associated with health checks, we can only make sure that return values are full healthy resources. So the multi-value returns up to 8 healthy records at each query, and a multi-value is a good load balancer, but it's not a substitute for having a load balancer. So here's an example. We can set up a multi-A record to set to the multiple IPs, so IPs, and then if they are all healthy, and they will all be returned back to the clients. So that's it for the basics of the Route 53. Next we'll be looking at the hosted zones. So we have the hosted zones here. So this is a container of records to define how to route traffic to a domain and its subdomains, and we have two kinds of it. We have the public hosted zones to allow the internet to resolve them for the public domains, and also we get the private hosted zones, and these can only be resolved from within your VPC, and you can define private URLs. So here the difference between the public hosted zones and private hosted zone is they are accessible. So a public hosted zone is accessible publicly, and you can have target being the public IP of an EC2 instance and the public IP of an application load balancer or a CloudFront distribution and or an S3 bucket website, for example. But in the private hosted zones, it's used from within your VPC, and it's very helpful to link to the private IP of your EC2 instance, private IP of your EC2 instance, or the private IP of your database RDS instances. So you are able to see there that the RDS instance is there, and so on. So now other things that would be good to know here for this exam is in case like you have a private hosted zones with a private DNS, and then in your VPC you have to you must enable two settings called enable DNS hostnames and enable DNS support also. So on the Route 53 you get support for DNS security extensions, DNSSEC, and it's a protocol for securing DNS traffic to verify the DNS data integrity and origin. It helps you to be protected against man-in-the-middle attack, MITM, and attacks on the DNSSEC. And Route 53 has support for both DNSSEC and for domain registration, and also DNSSEC signing. It only works for the public hosted zones. Finally, you can use here the Route 53 with a third registrar, in which case you buy the domain outside of AWS, but you still use Route 53 as your DNS provider. For this, you just update the NS records on the registrar and you appoint them to AWS. Now, onto health checks. So you get public health checks on Route 53. That means that, for example, if you have two ALBs in two distinct regions, then you can set up two health checks to check the health of these ALBs, application load balancer, and you can use the health check to link them to a specific DNS record, and this gives the automatic DNS failover. So bottom one is also auto scaling group that has been hidden by my view. So you have three kind of health checks. You get health checks that will monitor an endpoint health, so application, server, or maybe another AWS resource. You get health checks that will monitor the health checks, and they are called the calculated health checks. And you get health checks that would monitor the CloudWatch alarms, which give you full control, because you do whatever you want with a CloudWatch alarm. Okay, so you can monitor, for example, throttles of DynamoDB alarms, or on RDS, any custom metrics, which is very helpful for private resources. Now all of these health checks will publish also CloudWatch metrics. Like even if you ever need to see the CloudWatch metric, you can even see them. Now, so as we have said earlier, the calculated health checks, which is to combine health checks into a parent health check. And for this, you can use or and not conditions. You can monitor up to 256 children health checks, and in one parent health check, and you specify how many of the child health checks need to pass to make the parent health pass as well. So the use case of the calculated health check is to perform maintenance on your website without causing somewhat a disruption. For example, all the health checks to fail. So this was the calculated health checks. You can also monitor an endpoint using health checks. So we can monitor public endpoints, and health checkers all around the world will do here the we will do the HTTP request to health route that you have set for checking the health. Okay, and when you do something setup, you get about 15 health checkers that will check your endpoint health. So it needs to be a public endpoint, of course, and then the health checks are going to pass only if the endpoint is going to respond with 200 or 300 status code. Now there's a cool feature that you need to know about that is coming, that may come in the exam, is that the health check can be set up to fail or pass based on the value returned by the endpoint that you are checking. And if in the first 5120 bytes of the response you have some specific text that you specify, then you make health check pass or health else the health check pass check does not pass. So such of the things you can also actually program that based on the value returned, the endpoint can be set up to fail or pass. Okay, so now how do we do the health checks of stuff in private hosted zones? So okay, well, because the health checkers are outside of the VPC, they cannot access private endpoints, so private VPC or on-premise resources. And so therefore, to monitor the health of an EC2 instance, what you can do is that you can create a CloudWatch metric, then you associate a CloudWatch alarm with it, and then you base the health check to monitor the CloudWatch alarm itself. And this is how you would effectively monitor the health of an internal resource. And this one is the CloudWatch alarm, has been actually hidden by my view. So let's take an example of a solution architecture for multi-region failover with RDS instance. So we have a main database, and we have an asynchronous replication into a different zone. So we have US East 1 and US West 2 region. Then we have two ways. Either we set up an EC2 instance to monitor the health of the database and to expose an HTTP call to health-db route, and that is one way of doing it. Or option 2, which I like more, is to define CloudWatch alarm and link the CloudWatch alarm into a health check. Once the health check is off, we can link it to the CloudWatch alarm as well. So this is going to be linked to an SNS topic or an CloudWatch event, which is going to trigger a Lambda function, and then the Lambda function will update the DNS of your application into Route 53, and then promote your read replicas of US West 2, and effectively you have achieved automated failover using health checks and Route 53. So this is all about the Route 53, and I hope that was helpful, and I hope you also liked it. I will see you in the next one.